We will now look at examples for truth tables for the conditional and for the biconditional. We begin with an example that says, if you use optimizer gasoline, then you will not have engine knocking and you will enjoy driving. Translate this statement into symbolic form and construct a truth table. To do this, we will use the letters P, Q, and R. For letter P, we will assign you use optimizer gasoline. For Q, we will assign you will have engine knocking. And for R, we will assign you will enjoy driving. Now, we will translate the statement into symbolic form. Our statement says, if you use optimizer gasoline. So that is event P with an arrow. Then you will not have engine knocking. So not having engine knocking is the negation of Q. And we'll use our symbol for and. You will enjoy driving, and that is R. We're going to put this in parentheses because that is the entire then. So if we use optimizer gasoline, then we have both of these events occurring. You will not have engine knocking, and you will enjoy driving. Now, the next thing that we need to do is we need to take that statement in symbolic form, and we need to construct a truth table. So I'm going to write my statement at the top. And then we're going to begin setting up the truth table. So remember that for a truth table where we have 3 letters, we're going to have 8 different options. So I'm going to make a column for the P, a column for the Q, and a column for the R. For the P, I'm going to list out 4 trues and 4 falses. For the Q's, I'm going to list out alternating pairs, 2 trues, 2 falses, 2 trues, and 2 F's. And for the R, I'm going to alternate true, false all the way down the column. Then we're going to extend our table and we're going to write down what we're being asked to find. So across the top, I'm going to write if P, so P and the arrow. Then I'm going to open a parenthesis and I'm going to do the negation of Q, the symbol for and, the R, and close the parenthesis. So let's go ahead and copy what we can copy. We're going to copy the P column underneath the P. So again, 4 trues, and 4 falses. I'm going to copy the R underneath the R over here. So true, false, true, false, true, false, true, false. Now, for the negation of Q, I'm going to go ahead and do the opposite of what I see in the Q column over here. So instead of having 2 trues, I'm going to put 2 Fs. And then instead of 2 Fs, we're going to put 2 Ts. And we'll continue negating each of those values. So let's do the parenthesis part first. We have an and. So we want to keep in mind that if the first one is a false and the second one is a true, then that's going to be false. If they're both false, that will be false. If they're both true, the answer will be true. If the first one is true and the second one is false, the answer will be false. If we have a false first and a true second, the answer will be false. 2 falses will be false. 2 trues will be true. And a true and a false will be false. So now we are going to look at comparing this column to the P column. And so we're doing if P, then this column. So let's look at that. So if the first one is true and the second one is false, we have an answer of false. And again, true in the first one, false in the second one gives me a false. A true on the first one and a true on the second one gives me a true. A true on the first one and a false on the second one gives me a false. 2 falses produce a true. A false and then a true produces a true. And a false and then a false produces a true. And so again, this is the answer, the final answer to my truth table. Our next example says, determine the truth value of this statement, the negation of P, if and only if Q. If that's true, then the negation of Q, if and only if R. When P is false, Q is true, and R is false. So let's begin with the negation of P, if and only if Q. We're told that P is false, so the negation of P will be true. And then we have if and only if, and we know that Q is true as well. And we know that if the first statement is true, if and only if the second statement is true, the result is true. And let's move to our second set of parentheses. We have the negation of Q, if and only if R. So we know that Q is true, so the negation of Q would be false. And we know that R is false. And in this case, the first one is false and the second one is false with an if and only if in between. We know that that is equal to true. And so finally, let's look at our inside operation. We're saying that if the first one is true, then the second one is true. We know that that is a true statement. So the truth value of this given statement is that it is true. Our last example says to determine whether the statement is a tautology, a self-contradiction, or neither. And our statement is that P and the negation of Q that is in parentheses, if and only if, and then we have the negation of, in parentheses, P implies Q. So let's begin by setting up a truth table, which will allow us to determine whether we have a tautology or a self-contradiction or neither. So I'm going to make a column for P and Q to get myself started. Remember that in the P column we'll have 2 true and 2 false. And in the Q column we'll alternate true, false, true, false. Then let's begin working on the problem itself. So the first part asks me to do P and the negation of Q. So under the P, let's write down the P values: true, true, false, false. And under the negation of Q, let's write down the opposite of the Q values. So false, true, false, true. And let's do an and in between. So if we have true and false, the answer is false. If we have 2 trues, the answer will be true. If we have 2 falses, the answer will be false. And if we have a false and then a true, the answer will be false. So I'm going to go ahead and circle this one just so I can kind of keep my eye on it as we move to the second one. So for the second one, the first thing that I'm going to do is I'm going to write down the P and write down the Q. So just copying, underneath the P I'm going to do T, T, F, F. And underneath the Q I'm going to do T, F, T, F. Now, this is a conditional statement. If P, then Q. So let's go ahead and fill this out. If P is true, then Q is true. That is a true statement. If the first one is true and the second one is false, that is a false statement. If the first one is false and the second one is true, that is a true statement. And if they're both false, that is a true statement. And so again, I'm going to kind of keep my eye on this column for a second, and we need to do the negation of that column. So I'm going to do the opposites right here. So I will have false, true, false, false. And I'm going to circle that because that is what I'm going to be comparing to the other circled column. All right, so let's do the if and only if in the middle. So if they are both false, then the if and only if will be true. If they're both true, the if and only if will be true. If the first one is false and the second one is false, we've already done that, that's true. And we have a repeat here as well. 2 falses will also be true. And so our final answer is going to look like this. And notice that it has all trues in it, which remember that a tautology is a compound statement that is always true. So therefore, I can conclude that this is an example for a tautology.